Now, in this quick tip, I want to explain why it is that we have the radian system of measure. At first sight, if you think about it, a degree divides up the circle into 360 different pieces, but a radian divides that one rotation up into 2 pi pieces. And a fraction of 1 over 2 pi, my goodness, that seems pretty inconvenient. So why would anybody ever come up with this crazy system? Well, you could ask the same question about degrees. So let's answer the question for degrees first. And the answer for degrees is really simple and practical. The number 360 is divisible by all of these different integers here. 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, 20, 24, 30, 36, 40, 45, 60, 72, 90, and 100, 180. And what I mean by that is this. What if you wanted one, say, 72nd of a rotation around the circle? How many degrees would that be? Well, if you do it on your calculator, 360 divided by 72, it turns out at a 72nd of a full rotation is exactly 5 degrees. The point is it comes out even. We don't come up with some weird number that's hard to express. In contrast, suppose we had done something like this. What if we made each degree 1/100th of a rotation? Well, in that case, you don't get nearly as many even divisors. The integers that divide 100 are 1, 2, 5, 10, 25, 50, and 100. Notice how much shorter, how much richer this list is up here. And back in the days when people worked without the benefit of calculators, then having answers come out to be nice even numbers was just a huge advantage. And so really that is a primary reason why the degree system was invented. 360 is simply divisible by a whole lot of integers. All right then, why would we want to divide up the one rotation of a circle into 2 pi parts? What could possibly be the advantage of that? Well, the advantage comes when you start thinking about a circle with a radius of 1. So, for instance, suppose you made a road that was perfectly circular, and the radius of that road were exactly 1 mile. Now, if you wanted to drive all the way around that road, how far would it be? Well, the answer comes from the standard formula from geometry. The circumference of a circle is 2 pi times the radius. But if the radius is 1, then the circumference is 2 pi. So if you wanted to drive from the starting point up to the terminal point where you have, say, a 45-degree angle, well, what you would do is this. You'd know that all the way around is 2 pi miles. This would be pi miles, pi over 2 and pi over 4. It comes out to be a nice multiple of pi. So you could just go a quarter of a pi mile, and that would give you the place to stop in order to strike off that 45-degree angle. So the reason that radians is important, the first reason is this, is that it is equivalent to the arc length, the distance that you're traveling along the circumference of the circle. Well, that's all well and good if the radius of your circle is 1, but what if it's more? I've drawn another circle here now, and this radius, if that one is 1, then this one would be 1.5 out to here. So now, why are radians so convenient? Well, the reason they're so convenient is that this formula for circumference, you notice that 2 pi in there? That is really an angle in disguise. So there's a formula known as the arc length formula, and it answers this question. Suppose you want to measure this distance along the circumference of the circle for a particular angle, and you have measured the angle in radians. Then it turns out that the arc length, the distance along the circumference here, that arc length is always given by the measure of the angle in radians times the radius of the circle. So in this particular case, what we're saying is that we have a radius of 1.5 and we go up through 45-degree angle. Well, the 45-degree doesn't help us at all, except that it tells us how to convert into radians. So we convert that to radians, pi over 4. We multiply by the radius of the circle. The radius of the circle is 1.5. That's the same as 3/2. And we get 3 pi over 8. So 3/8 of pi is the arc length that's marked off by that 45-degree angle when the radius is 1.5. Now let me just give you a little bit of vocabulary here. Very often mathematicians, rather than say, well, it's the arc length that's sort of in between those two, well, we need a nice word that expresses that quickly. So mathematicians will also often say it's the arc length subtended by that angle. Now, last of all, let me mention that you don't have to leave the pi like this. Of course, we all know that pi has a decimal approximation. So instead of saying that it's 3 pi over 8, which is an exact value, we could also say that it is this value. We take 3 times pi divided by 8 on our calculator, and we get about 1.1781 if we were to round off. So that would be about 1.1781. Now, a natural question would be, well, what are the units? Well, we don't know because I didn't specify, right? But if this were, as in the previous example, actually a road, and this were 1.5 miles, then this distance would also be in miles. It'd be about 1.1781 miles along this arc right here.